Last time I left you hanging with this piece of code generated by Clang. The code on the left sums the integers from 1 to n in a for loop. We noticed that the assembly doesn't look like there is a loop. Let's actually try to read it now. First of all, if you don't know how these register names work, I want you to only look at the character in the middle. For our purposes, edi, for example, is basically just the variable d. That's the function argument in this case. First, we skip the entire thing if n is less than 1, and then we return... Wait, bonus! What is this XOR something with itself business? Well, all the bits match, so the result is just 0. So why don't we just assign 0 to the register? There's actually a bunch of things going on, but the short version is that, well, it's a smaller instruction. It takes fewer bytes to write the instruction XOR EAX, than the instruction move AAX 0. Okay, on to the real work. This LEA instruction is pretty funky, and I'm not going to explain why, but it can efficiently do some simple calculations, like this one down here. A gets C plus 2 times D. You can't do arbitrary expressions there, but this one happens to work. Don't worry about it. We're only reading this, so the rules for what exactly you can write here doesn't really concern us. If the compiler wrote it, it's fine. Recall that D is the function argument here. It's really n. So A gets n minus 1, C gets n minus 2, gets multiplied by A, and then shifted to the right by 1 bit, which is really a division by 2. By now, we have n minus 1 times n minus 2 divided by 2. Finally, we put that in A, and then we add 2n, this is still n, and subtract 1. And that's the result. So what Clang has come up with, as code for the loop on the left, is return n minus 1 times n minus 2 divided by 2 plus 2n minus 1. It seems pretty random that a general purpose compiler is able to do sums like this, but I think it's pretty cool. However, this is actually a pretty funny formula to do it with. I would have maybe said half n squared plus half n, or maybe the most famous way to compute this sum would be n plus 1 times half n. So what's up with this formula? Let's talk about it next time.